Hey guys, here we go. We're going to do some another thing for polynomials, and this is going to be dealing with polynomial inequalities. And the first thing we're going to talk about is the definition of polynomial function. Now, we've been using them, but we never really wrote down the official textbook definition. So here we go. This is how you would see it in a book. And what it would say would be something to this effect. It would say f of x equals, now this is where it gets a little weird, an x to the n plus an minus 1 x to the n minus 1 plus dot 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 a2 x squared plus a1 x to the first plus a0. And what all this is, don't get nervous when you see some weird stuff, right? We talk about how you have to know what the pieces mean. And for this thing, what we would have to be is that let n be a non-negative integer. And so that's just some number. So, for example, if n was 2, that would just be this. This is our regular quadratic. If n was 3, it would have a to the a3 x cubed plus all the rest. Some things we need to talk about. This thing here at the end here, that would just be a regular number, and that would be called the constant term. So that's a constant term. And that actually has something, when we actually graph this, this is really the y-intercept. When we graph this, this guy in the front here is the lead coefficient. And that's important because that's going to tell us which directions our polynomial is going to be pointing. And so a couple other things, like the n here, this is called degree n, just like we've talked about in class. And these a's are coefficients. So now they don't just say a is a coefficient because they all have a little, they're all sub something. So think like this, ai are coefficients. There's an e in there. And so, like, for example, if a1, that would be this guy. a2 would be this guy. a0 is this guy in the end. So don't get freaked out when you see some crazy polynomial written out. Now, when we have even powers, okay, even degrees, all right, so if the biggest coefficient, the biggest power, that's our degree, if it's even, what you're going to notice, they're going to point in the same direction. They head in the same direction, the endpoints. And so, they'll either be pointing up or they'll point down. Okay? And this could have like several bumps. This could be a single, could be a parabola. And so when it's pointing up, that means the number in front, the lead coefficient, is positive. And if the lead coefficient is negative, it's pointing down. And once again, how you're going to see this, and don't freak out, what you might see would be, it would say an is greater than 0. That means above 0 is positive. Down here it might say an less than 0. That would be negative. Now, odd degrees point in opposite directions. So the endpoints will point in the opposite direction. So now, if an is greater than 0, now think about that, greater than 0. That means if an, the lead coefficient, is positive, it's going to point, it'll look something like this, right? You can have a bunch of bumps in the middle, right? Peaks and valleys. But generally, one's going to go up, one's going to go down. And if it's less than 0, if our lead coefficient is negative, that means it's going to go look something like this. Okay, so the left side is going to be pointing up and the right side is going to be pointing down. Alright, so let's see what we're going to do with this. So we have an example here, and so we have this polynomial function f of x, x cubed plus 2x squared minus 5x minus 6. And what they're going to want us to do is sketch the function without a calculator. All right, now we've been talking about this, and in class I've been showing you kind of like little tricks, but now we're actually going to like really like kind of go through what we have to do. So first thing, let's see now. When I look at this thing, I see the cube, and like if you look right above, so the cube, it's got to be, and it's positive, right? The number in front is positive. So to me, it's going to go something like this. Okay, so that's that so far. And then in the back number, the -6, that's the y-intercept. So that's all I know so far. I have an idea. I know it's going to be pointing in this general direction, and the y-intercept is -6. Now, we could do all those things that we've been doing before, like Descartes' rule of signs, and, to see, oh, which ones are positive, how many could be on the positive side, how many could be on the negative side, and all that stuff is totally legit for this kind of problem. But for now, what we're going to do just for this little video, we're just going to go over like the basics. So now, what you want to do now is you want to factor this. You want to break this down. Okay, so you want to factor this thing. Now, to save time, I'm going to give you the factors for this problem. So it's x minus 2, x plus 1, and x plus 3. And right, all that stuff that we've done, like the rational root theorem and all those things, it's totally legit for this, right? But let's just save a little time here. And so now what I got here are, these are the factors, right? So that means x equals 2 is a root, otherwise a 0, right? So these are my zeros. So x equals 2, or x equals -1, and finally x equals -3. Now, actually from this, I have a really good sense of what this graph looks like. Okay, so I'm just going to make a little graph. We have plenty of room. And so I'm going to put these points on here, right? So -1, -2, -3, +1, +2, +3. I'm not putting anything on the y because I really don't know how high this thing is going to get. The only thing I do know is this. At -6, the y-intercept. That's the only thing I know. And I know that at x equals +2, I have a root, and at -1 and -3. So I'm going to put those roots on there. And if we look at our picture that we made before, right, this shape here, it's got to go something like this. So when I look at this, right, it's got to go something like this. So that's what it's going. And I really don't know the height of this thing, but I'm just making a sketch. I didn't say graph. I'm sketching. And this, I have a really good feeling about this graph like this. And I'm going to label it f of x. Label our graphs. And that's my graph. Now, it says make a sign chart for this thing. All right, well, here's a sign chart. What you do is you put your roots on the number line. Okay, so I got -3, -1, and +2. And then what you want to do is you want to pick a number in between and check. So for example, like in between here, right, I can check 0. And what I want to do is I want to check the 0. So, right, if I plug in 0, right, it'd be 0 minus 2 is negative, so that'd be a negative. 1 plus 0 is positive, and 0 plus 3 is positive. And if I actually did this, right, so let me clean this up. You normally only do 1. I'm just cleaning it. I'm just showing you how to do it, the steps. Right? Negative times positive means in between -1 and 2, it should be negative. Right? It should be negative. Right? And negative means below the x-axis. That's what that means. And that's how we do a sign chart. So below the x-axis, like this. So look, let's go over here. -1, -3. This is telling me it's supposed to be, it's above the x-axis. I'm looking at the picture, right? And let's just check to see what that picture really looks like. And so if we turn that on, let's graph that. Hey, look at that. Look at that. It looks very similar to our graph. All right. So we're doing good. All right. So let's check -2, right? So I'm going to check -2. Okay, I'm going to plug it in. Negative is -4. That's negative. I don't care about I don't care about the number itself. I just need positive, negative. -2 and +1 is a negative. -2 and +3 is a positive. And if I multiply these, negative, positive means positive. and that's above the x-axis, just like we have in our drawing, just like we have in our drawing. And so now we're going to go through the whole interval here, right? And so let's plug in a number over here, something like -4, right? Check -4. And plug in -4, so negative, negative, that's a negative, 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 negative. And when we do that, the whole thing is negative. So that's my real sign chart. This is the real sign chart. This is the scrap. This is the real one. And I need a number over here, so I'm going to check like a 3. And you can check whatever number you want. It doesn't matter. Just, you know, be careful. 3 minus 2 is positive. 3, that's positive. That'd be positive. And so this one here is positive. And so just like we see in our drawing, this is above and this one's below. So that's how we make a sign chart. But what if the question was different? What if the question said, state the interval where this function, the one we have, was greater than 0? And what you got to know is that when they say greater than 0, that means above the x-axis. This is above x-axis. Now, are you allowed to equal 0? Right? Because now we're going to do interval notation. Are you allowed to equal 0? And the answer is no. So I just need the zones where it's above 0. So above would be from -3 to -1. And since I can't equal, I'm going to use, right, these are open with, and let's see what we got here. Where else is above? Oh, over here, right here. This is above. From 2 up, 2 to infinity, 2 to infinity. And it's open because I can't equal the 0. So let's try it again. Where is this thing, this function, less than or equal to 0? Well, that's below. But now the trick is it's allowed to be equal. That's good for us, right? Actually, it doesn't really matter. It's just you got to be careful with your brackets. So less than 0 is negative. So I need from negative infinity to -3. And now, though, I'm allowed to equal -3. You never equal infinity, though. And I need negative below, also -1 to 2. Oopsie-daisy. Undo that. Square brackets, right? And it's from -1 to 2. And that's it. And in class, what we're going to do is we're going to break these things down, and we're going to, make our little sign charts and write our intervals. All right. Have a nice night.